Hi, Year 10. This is the third in a series of lessons for the topic of equations for the new New South Wales curriculum. This topic is part of the advanced pathway. Now in this lesson, we're going to cover quadratic equations. So this is what we've covered so far. In our first lesson, we looked at linear equations, including equations involving fractions, binomial numerators, and pronumerals on the denominator. And then last lesson, we looked at literal equations. So recall that quadratic equations may have one, two, or no solutions. Let's review this. Suppose we want to solve x squared is equal to 0. When we're solving any equation, we want to get x by itself on the left-hand side. So we need to move this squared. And the opposite operation of squared is square root. So I'm going to do the square root of both sides. And the square root of 0 is 0. So one solution. How about this one? X squared is equal to 9. Again, I'm going to move that squared over by doing the square root of both sides. But in this case, there's going to be two solutions. And they are plus or minus 3. Now, let's just have a quick look at that. Positive 3 times positive 3 is equal to 9. And negative 3 times negative 3 is also equal to 9. So two solutions. And then finally, suppose we have x squared is equal to negative 1. Again, let's do opposite operations and do the square root of both sides. In this case, I end up with the square root of a negative number, which doesn't exist. So in this case, there are no solutions. Now, they were fairly simple quadratic equations. But suppose we have a quadratic trinomial. So remember, that's one with three terms, like x squared plus 5x plus 6. We can factorize and then use the Null Factor Law to solve the equation. So let's have a look at an example that's already factorized. X minus 2 in brackets, x minus 1 in brackets is equal to 0. So the Null Factor Law is really, really useful law. It says if I have something times something is equal to 0, then either the first thing is equal to 0 or the second thing is equal to 0. And it makes sense because if I make this 0, it wipes the whole thing out. If I make this 0, it wipes the whole thing out. So what we've got to do in this case, because this is a product, there's a times sign in there. We've got to make that 0 and then make this 0. So all we do is ask, in each case, what x makes 0. So what makes 0 here? 2. And what makes 0 here? 1. And that's our solution. Let's look at a couple of examples. Solve x minus 2 in brackets multiplied by 2x plus 1 in brackets is equal to 0. So either this is equal to 0 or this is equal to 0. What makes 0 here? 2. What makes 0 here? Now, if you're stuck, what you can do is just write it out and solve it. It's just a simple linear equation. So 2x plus 1 is equal to 0. Take your 1 over. 2x is equal to negative 1. Divide both sides by 2. X is equal to negative 1/2. Now, after you've done this a couple of times, you'll start to see a pattern. But our answers to that first question are 2 and negative 1/2. Now let's look at the second question. We've got x multiplied by x minus 3 in brackets is equal to 0. So either this is equal to 0 or this is equal to 0. And we can easily see that 3 is going to make 0 here, and 0 is going to make 0 here. So our answers are 0 and 3. Now, our quadratic equations aren't always going to be factorized, so we need to review expanding binomial products and then factorizing quadratic trinomials. So recall, to expand binomial products such as x minus 2 in brackets multiplied by x plus 3 in brackets, we use FOIL, which stands for first, outer, inner, last. Okay, here we go. X times x is x squared. X times 3 is 3x. Negative 2 times x is minus 2x, and then negative 2 times positive 3 is negative 6. So first, outer, inner, last. Let's collect these two together. 3x take away 2x is 1x. So there's the expansion. Let's try another one. First, so that's 2x squared. This outer terms is 4x. Inner terms is negative x. And the last term is negative 2. Collect these two together. 4x take away x is 3x. There are two special products, perfect squares and difference of two squares. And a perfect square just looks like this, x minus 3 all squared. And we can write it like this and just do FOIL on it. But there is a shortcut. Have a look at this. First one squared. Take away 2 times 3 times x plus, because negative times a negative is a positive, plus 3 squared is 9. So you might like to practice that. The difference of two squares will look like this. We'll have the same elements, so they're both x's, they're both 3's, but different signs. And when we do FOIL on this, the middle terms cancel out, plus 3x minus 3x, and we end up with x squared minus 9. It's called the difference of two squares because it is the difference of two squares. 9 is 3 squared. Now we need to be able to factorize quadratic trinomials, and a quadratic trinomial has 3 terms and the highest power of x is 2. So for example, x squared plus 5x plus 6. And quadratic trinomials come from expanding binomial products. So for example, x plus 3 multiplied by x plus 2, if we do FOIL on that, we end up with x squared plus 2x plus 3x plus 6, which is x squared plus 5x plus 6. So how do we factorize x squared plus 5x plus 6? Well, it's important to know where these terms come from. This first one, this x squared term, it's the first terms multiplied together. So this one times this one. The 6, that's the last terms multiplied together. And this 5x, that comes from the outer and inner products added together. So let's have a go at factorising it. Firstly, I know the only way to get x squared has to be x times x, so I'm going to put that in. Secondly, I know that the signs are going to be positive, so I'm going to put plus and plus in. Now this is what we say to ourselves. What factors of 6 add to 5? And that has to be 2 and 3, doesn't it? And order is not important here. We can write x plus 2 multiplied by x plus 3, or the other way around. Let's have a look at a couple more. So in this case here, the only way to get x squared is x times x. The signs are both going to be pluses. I want factors of 6 that add to 7. That has to be 6 and 1. And this one here, again, it's going to be x times x. Both of the signs are going to be pluses. I want factors of 8 that add to 6. That has to be 4 and 2. Now, so far, we've only done questions like this. But what if there are different signs, like this, or this, or this? These two are very similar, and these two are very similar. I'm going to show you why. The key is this final sign here. In this case, it is telling me that the signs in the brackets are going to be the same, because the only way to get positive 6 is with 2 pluses or 2 minuses. And in this case, looking here, they're going to be pluses, and in this case, they're both going to be minuses. All right, so signs will be the same. In this case over here, this is telling me that the signs are going to be different. You see that? The only way to get negative 6 is with a plus and a minus. All right, once we know that, then we can look at this middle term here. In this case, this is going to be a sum. So we've got 3x plus 2x gives me 5x. And in this case, I've got negative 3x, take away 2x. It's still a sum, but it's a sum in a negative direction. So I'm going to say what factors of 6 add to 5, even if they're adding in a negative direction. But over here, in this case, this is going to be a difference because the signs are different. I've got 3x take away 2x or negative 3x plus 2x. So I'm going to say what factors of 6 have a difference of 1. Okay, let's work through these. X squared minus 7x plus 10. So look here, this means the signs are going to be the same. They're both going to be negatives. We want factors of 10 that add to 7. That is 2 and 5. Order is not important. This one, looking here, signs are going to be different. We want factors of 8 that have a difference of 7. Well, that's 8 and 1. Now furthermore, looking here, we want the bigger one to be negative. So that's the 8. So let's just check that one out. We've got x take away 8x gives us negative 7x, so that's correct. Okay, down here, the same question, but different sign here. So signs are different, and we're going to have 8 and 1, but this time we want to make the bigger one positive. So the 8 becomes positive, the other one is negative. Let's check this out. We've got negative x plus 8x, which is plus 7x. And then finally this one, signs are different. We want factors of 12 that have a difference of 4, that's 6 and 2. We want the bigger one to be positive. So there's our answer. Now the whole point of doing that review is because we want to be able to factorize quadratic equations and then solve them using the null factor law. So let's have a go at these two. In this case, signs are going to be different, and we want factors of 63 that have a difference of 2, so that's 9 and 7, and we want the bigger one to be negative. So x minus 9 and then x plus 7. Now let's solve this. What makes 0 here? 9. What makes 0 here? Negative 7. There's our answers. Over here, signs are the same, and they're both going to be pluses. We want factors of 24 that add to 14, and that of course is 12 and 2. What makes 0 here? Negative 12. What makes 0 here? Negative 2. Now, like all equations, we can check if our solutions are correct by substituting back into the equation. So if we've got a question like this and we solve it in a test and we get x is equal to 3 and negative 4, we can do a quick check. Substitute our 3 back into here and see if we get 0. 3 squared plus 3 minus 12, well, that's 9 plus 3, take 12. Yes, that is equal to 0. It's correct. How about the negative 4? Don't forget to square that in brackets. So that's 16, take away 4, take away 12. It is also equal to 0. It is correct. Now, if the quadratic trinomial has a leading coefficient other than 1, it is a little bit more difficult to factorize. Like this one, 2x squared take away 11x plus 5 is equal to 0. And the problem here is the 2. Now, we are going to cover the quadratic formula shortly, and that might be a better method for you. But I still want to revise how to factorize these types of trinomials. So the key is to multiply the first and the last coefficients. We get 10. Now looking at the signs, we know the signs are both going to be the same. They're both going to be minuses. We want factors of 10 that add to negative 11. That of course is going to be negative 10 and negative 1. Now this is what we do. We're going to rewrite the equation and we're going to split this middle term into negative 10x and then negative 1x. And what we've actually done here, remember this has come from the inner and outer products, we've split it back out into those two. Now what we do is factorize the first two terms and factorize the last two terms. So these two, common factor is 2x. Here, common factor is negative 1. So like this. Now these two brackets should match. If they don't match, you've done it wrong, or these terms are around the wrong way. And that can happen. But in this case, we've got common factor, so that comes out the front, and we have 2x take away 1. And there we have it factorized. Remember, we can always expand it out to check whether we're right. Now let's solve it. What makes 0 here? 5. What makes 0 here? 1/2. Here's our second example. Solve 3x squared plus 5x minus 2 is equal to 0. Okay, multiplying first and last coefficients gives us negative 6. This negative is telling us that the signs are going to be different, and this is going to be a difference. So we want factors of 6 that have a difference of 5, and that is 6 and 1. Furthermore, we want the bigger one to be positive. So that's positive 6, negative 1. All right, let's split this term up into plus 6x minus x. Now let's factorize the first two terms and the last two terms. Common factor here is 3x. Common factor here is negative 1. Do these two match? Yes, they do. It's a common factor. Bring it out the front and we're left with 3x, take away 1. And don't forget to finish this off. We still need to solve the equation. What makes 0 here? Negative 2. What makes 0 here? 1/3. What happens if we can't factorize? We do have a couple of different methods, and the first one I'm going to show you is called completing the square. So here's an example, x squared minus 6x minus 5 is equal to 0. And we can see that we can't factorize this because we'd want factors of 5 that have a difference of 6. And there's no such thing. All right, here's the method. I'm going to take this 5 and move it over the other side, and I'm going to leave a gap. Now, we want to put a number in here so that this side here is a perfect square, and it's really easy to do. What we want to do is find the term in x and the coefficient, which is negative 6. And all we do is halve it, square it. You can see how I haven't included the negative there, because when we square it, the negative's going to go. So I can pretty much ignore that. So half of 6 is 3. 3 squared is 9. And I want to put a plus 9 in. I've completed the square. But of course, I've changed the question, haven't I? I've just introduced a 9 out of nowhere. So whatever I do to one side, I have to do to the other. All right, let's write this as a perfect square. This is x minus 3 all squared is equal to 14. Now we're going to solve the equation. Square root both sides. Don't forget the plus minus. And then finally take the negative 3 over, and there's our solution. Here's another example. Solve x squared plus 4x minus 6 equals 0 by completing the square. Okay, start by moving this 6 over. Look for the term in x. Here it is. The coefficient is 4. Halve it, square it. Half of 4 is 2. Squared is 4. So 4 goes in here. Whatever you do to one side, do it to the other. Okay, let's complete the square. This is x plus 2 all squared. Okay, it's half of this number, or it's the square root of this number. So x plus 2 all squared is equal to 10. Square root both sides, don't forget the plus minus. X plus 2 is equal to plus or minus root 10. Move the 2 over. There's the answer. Here's another example. Solve 2x squared minus 4x minus 5 equals 0 by completing the square. Now here's the thing. This method isn't going to work if we have a leading coefficient other than 1. So we need to get rid of it. We're going to divide everything by 2. And it means the question is going to be a little bit uglier than the previous one. But the method still works. Take this 2.5 or 2.5 over the other side and complete the square. So here's the term in x, halve it, square it, gives me 1. Do that to both sides. Complete the square here is x minus 1 all squared, and that's equal to 3.5. Do the square root of both sides, don't forget the plus or minus, and move the 1 over. There's our answer. All right, let's do the quadratic formula. Now, I'm going to show you the proof of it. If this is too much, skip ahead. If we want to solve this equation ax squared plus bx plus c equals 0 by completing the square, we can't have any leading coefficient. So we need to divide everything by a. Okay, now we're going to follow the same method we just did. I'm going to move this c on a over the other side. Look for the term in x. Here it is. Halve it, square it. So half of this is b on 2a, and then we want to square that, which of course is b squared on 4a squared. Whatever I do to one side, I do to the other. Now let's complete the square. So this is, remember it's going to be half of this, x plus b on 2a all squared. And all I've done here is turn this around. Right, square root both sides, don't forget the plus minus. And then finally take this over the other side. And if I just tidy that up and make a common denominator, we have the quadratic formula, which is this. So given any quadratic equation in the form ax squared plus bx plus c equals 0, we can find the solutions by using this formula. And this is whether it can be factorized or not. So x is going to be equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now here's an important point. The solutions to a quadratic equation are called the roots or the zeros, and that's because they are the x-intercepts of the graph of the equation. We're going to look at that further when we look at nonlinear relationships. Here's our first example. Find the roots of the equation x squared minus 6x minus 5 is equal to 0. Now remember, roots mean solutions or values of x. This is the same question we did before via completing the square. So let's see if we get the same answer. In this case, we're going to use the quadratic formula. A is the coefficient of x squared, so that's 1. B is -6, and C is -5. And all we have to do is substitute into the formula. Now, your biggest issue is going to be these negatives. And I would encourage you to substitute them in brackets, like this. And the reason for that is because -6 all squared is very different to -6 squared. Let's just have a look at that. -6 squared is -36. -6 all squared is -6 times -6, which is +36. You'll make this mistake a couple of times and you'll end up with a negative under this square root. And then you'll learn your lesson, hopefully. Tidying all of that up, we end up with 6 plus or minus the square root of 36 plus 20, which is 56, all over 2. Now we need to simplify this. Now thinking back to the work you did on surds and indices at the beginning of Year 9, hopefully you remember how to simplify a surd. We are looking for the highest perfect square that goes into 56. There's the perfect squares there. The highest one is 4. So we can rewrite root 56 as a square root of 4 times 14, which I can split up, which gives me 2 root 14. Now, of all the techniques that you learnt with surds, this is probably the most frequently used going forward. So make sure you practice that. So I can rewrite this as 6 plus or minus 2 root 14 all over 2, and then factorising the numerator I get 2 outside of 3 plus or minus 14, square root of 14 all over 2, and these 2's will cancel, and there is our answer, which is the same as we got before. Now this is called exact form or surd form. Here's example 2. Find the roots of the equation 3x squared minus x minus 18 equals 0 to 3 significant figures. So in this case, we're asked for an approximation, so we don't need to simplify our surds. But we still need to use the quadratic formula. So A is 3, B is -1, C is -18, and substituting in I get this. See how I've used my brackets. All right, tidy this up, you put it straight in the calculator, that gives you 217. And simplified, we have 1 plus or minus root 217 all over 6. Now, the calculator doesn't have a plus minus button, so you've got to do this twice. 1 plus root 217 all over 6, and then 1 minus root 217 all over 6. And our answers to 3 significant figures are -2.29 and 2.62. Remember, significant figures are non-zero numbers unless the 0 appears between 2 other significant figures. So you can see 1, 2, 3 significant figures in each case. Okay, let's finish this off with some applications. We'll start with word problems. A skydiver jumps from a plane. The height in meters above the ground after t seconds is given by h is equal to 1900, take away 5t squared. What height was the plane when the skydiver jumped? So this means what height was the plane when t was equal to 0? You might also see the words initially. What height was the plane initially? If you ever see that, it means t is equal to 0. So all we have to do is substitute 0 in here. So the plane was at 1900 meters. Approximately how many seconds will it take for the skydiver to reach the ground? So we need to interpret some of our variables here. H is the height in meters above the ground after t seconds. So if the skydiver is on the ground, the height above the ground is 0. So we want to substitute 0 in for h. This is just a simple quadratic equation. 0 is equal to 1900 take away 5t squared. Let's take this 5t squared over the other side. Divide both sides by 5 and then do the square root. Now we will get plus or minus 19.5 seconds, but there's no such thing as negative time, so we can disregard the negative. Therefore it takes 19.5 seconds to reach the ground. How many seconds does it take for the skydiver to fall 1,000 meters? So again, we need to interpret our variables. H is the height in meters above the ground. So if it starts at 1900, and the skydiver has fallen 1,000, then we want h to be 900. Does that make sense? Subbing it in, let's take the 900 over here and the 5t squared over this side. 5t squared is equal to 1,000. Divide both sides by 5, do the square root, and again let's disregard the negative. It takes 14.1 seconds for the skydiver to fall 1,000 meters. Now sometimes word problems will require you to create the equation and then solve it. Like this question, a number and its reciprocal add to 2.9. What are the numbers? Now in this case we need to define a variable. So we're going to say let the number be n. Now what's the reciprocal of n? Remember this is n over 1 and the reciprocal means turn it upside down. So the reciprocal will be 1 over n. So n plus 1 over n is equal to 2.9. Now do you remember how to solve these sorts of equations? We're going to multiply every term by n, like this. N times n is n squared. These n's cancel out, so that's equal to 1, and equals 2.9n. And tidying it up, we get n squared minus 2.9n plus 1 equals 0. And we're going to use the quadratic formula to finish that off. I'm going to let you finish this question. The question asks what are the numbers, so you need to give both numbers, n and its reciprocal. We can also get equations from formulae. Find the value or values of a in the formula c squared equals a squared plus b squared minus 2ab cos c. If big C is equal to 60 degrees, little c is equal to 7, and b is equal to 8. So we'll start by substituting in. 7 squared is equal to a squared plus 8 squared minus 2 times a times 8 times cos 60. Now, if you do cos 60 on your calculator, that's equal to a half. So we can tidy this up a bit. 7 squared is 49, 8 squared is 64, and 2 times 8 times a half is 8. Now let's form a quadratic. We've got a squared minus 8a, and let's take this 49 over the other side. That's 15. So a squared minus 8a plus 15 equals 0. Now we would always consider factorising, and we can factorise that. We have got a minus 3, a minus 5 is equal to 0, so a is either equal to 3 or 5. Okay, we've got two concepts left. I know there's been a lot in this particular video. We can reduce an equation down to a quadratic. If you have a look here, this is not a quadratic equation, this is a quartic equation because we've got an x to the power of 4. But if we make a simple substitution, it's going to reduce down to a quadratic equation. And that substitution is going to be let u equal x squared. Because x to the power of 4 is the same as x squared all squared. So I can put u here and u here, and have a look what happens. See how that's a quadratic? U squared minus 13u plus 36 equals 0. Now always assume that this is going to factorise. And in fact it does. We've got u minus 4 and then u minus 9 is equal to 0. Let's solve for u. U is equal to 4 or 9. And we're not finished because it hasn't asked us to solve for u, it's asked us to solve for x. So we're going to substitute back. Instead of u, we're going to put x squared there. So x squared is either equal to 4 or 9. If we want to solve x squared is equal to 4, we take the square root of both sides, so that will be plus or minus 2. And solving x squared is equal to 9, we're going to get plus or minus 3, so there are 4 answers. Let's try one more. By making an appropriate substitution, solve the equation 2 times 4 to the x minus 5 times 2 to the x plus 2 is equal to 0. Now, obviously this is not a quadratic, but by making the substitution u is equal to 2 to the x, we will get a quadratic. Now the key is here. 4 to the power of x is the same as 2 squared to the power of x. And when I raise a power to a power, I multiply the indices. Order is not important with multiplication, so I could rewrite that like this. 2 to the power of x all squared. So let's do that. So I've got 2 times 2 to the power of x all squared minus 5 times 2 to the power of x plus 2 is equal to 0. And u is going to go in here. and in here, and voila, I have a quadratic. Now, we can factorize this. Let's multiply the first and the last coefficients. That's 4. I want factors of 4 that add to 5. That's 4 and 1. They're both going to be negative. So let's change this middle term into minus 4u minus u. Factorizing the first two and the last two, I get this. And u minus 2 is a common factor. Now let's solve it. What makes 0 here? A half. What makes 0 here? 2. Now don't just stop there. We're not solving for u. We are solving for x. So let's substitute back in. 2 to the power of x is equal to a half, or 2. Now, 2 to the power of x is equal to 2. That's fairly easy. X would have to be 1. But if 2 to the power of x is equal to a half, what is that? How do I write this as a power of 2? Do you remember? It's negative 1, isn't it? So our answers, x is equal to 1 and negative 1. Okay, last thing I promise. Recall, we can write a linear equation for this pattern. The pattern is 3, 5, 7, 9, 11. How do we know it's linear? It's going up by the same amount each time. And remember, if we want to write this as an equation, we would start with Tn is equal to 2 times n, because this is what it's going up by, 2 each time. And then we'd substitute in a point, so 2 times 1 is 2. How do I get from 2 up to 3? I'm adding 1. I'll just check it out with this one here. 2 times 2 is 4, plus 1 is 5. It's correct. And with the quadratic equation, we can do the same thing. But how do we tell that this one is quadratic? Let's see what it's going up by. From negative 2 up to 1, we're adding 3. And from 1 up to 6, we're adding 5. And from 6 to 13, we're adding 7. And from 13 to 22, we're adding 9. So what we say in this case is the second differences are constant, or they're the same. And what I mean by that is, it doesn't go up by the same amount each time, but if we take the second differences, look at this, plus 2, plus 2, plus 2, the second differences are the same, and that's what makes it quadratic. So the secret to forming a quadratic equation is to add a line for the n squared in the table. So here I've got n and n squared, and there's my pattern there. And I need to find a relationship between n squared and Tn, or it might be between n squared and n. Who knows? Let's have a look and see if we can figure it out. Is there anything between 1 and negative 2, 4 and 1, 9 and 6? Yes, that's subtract 3, isn't it? So if I take n squared and subtract 3, I think I have the pattern. Let's just check that out. So here's my suggestion. Tn is equal to n squared take 3. Let's test it. N squared is 1, take away 3 is negative 2. N squared is 4, take away 3 is 1. This works, doesn't it? Okay, so there's our pattern. All right, here's one more. I've got 2, 6, 12, 20, 30. Is it quadratic? Let's just see if it is. Here we're adding 4, adding 6, adding 8. It is, isn't it? Adding 10. So those second differences are constant. So we need an n squared. 1, 4, 9, 16, 25. Now here from here to here I'm adding 1, then adding 2, and then adding 3, and then adding 4, and then adding 5. So in this case, it's going to be n squared plus n. Let's see if that's right. 1 plus 1 is 2, 4 plus 2 is 6, 3 plus 9 is 12. Yep, it's correct. So there's our formula. Okay, that was a big lesson. Our next lesson is on the discriminant.